my name is Brett Mooney and I'm part of Team Igloo with Texas A&M University's Capstone program. Igloo presented us with a project to design an analysis tool in order to quantify the heat transfer within a consumer ice chest like this one here. The industry-wide performance test involves seeing how long it takes for an ice-filled cooler to raise its temperature from 10 degrees Fahrenheit to 40 degrees Fahrenheit. Within this test, there are three distinct phases. The first phase is when the ice is completely solid, to when the first drop of water forms, which is less than 32 degrees Fahrenheit. The second is when there is a mixture of ice and water within the cooler, which holds constant at 32 degrees. And the last is when the ice is completely melted and the temperature of the water rises from 32 degrees to 40 degrees Fahrenheit. The program, which we created, models various heat transfer modes and outputs the time for each phase as well as the total time for the test. The inputs to our model include the shape, dimension, and other parameters, such as if a cooler has a seal or not, just like this one has right here. The analysis tool that Igloo tasked us to create will aid in the design process for the Igloo engineers, while saving time and money on new and current projects.
The analysis tool that we created takes inputs from an Excel file where the user inputs dimensions and material properties of a particular cooler they want to test. Our MATLAB program then takes this information and runs an analysis on the heat transferred through the cooler and predicts its ice retention time. It also performed several tests to analyze the cooler if it had different dimensions.
Examples of these tests include
if the insulation layer thickness was changed, if you take dimension from the width and add it to the height, if you change just the dimension of the side insulation, and it also analyzes what would happen if you added a seal or a foamed lid to the cooler.
In order to validate our model, we need to run experiments on the coolers themselves. We filled the coolers with ice and placed thermocouples inside to capture the temperature inside the cooler throughout the test. After multiple experiments, we used statistical analysis to compare the experimental data to the values calculated from our model. From these experiments, we were able to validate our model to ensure its accuracy.
With our innovative design, the Igloo engineers will be able to design better performing coolers in less time with less money, which was the aim of this project.